Assalamualaikum warahmatullahi wabarakatuh. Welcome to PMC 500 Statistical Reasoning in Education. Today, we are going to continue with another lecture of Analysis of Variance or ANOVA. I am Dr. Nur Asniza Ishaq. You can call me Dr. Ija. So the objective for our lecture today is that we are going to I'm going to explain, and perhaps at the end of the class, you'll be able to analyze and interpret data of one-way ANOVA using SPSS. So previously, we have discussed on how to understand one-way ANOVA by looking at the mean difference for case sample. And then we have discussed Posthoc Test, comparing using multiple comparison. And I have explained one example of using a one-way ANOVA analysis. And for this lecture, I'm going to continue explaining another example of an analysis using ANOVA. So now let's look at example 2 for analyzing data using ANOVA. So in this example, a teacher wants to investigate the effect of 4 teaching methods on student achievement to learn science. By using SPSS file, there are scores obtained for 4 different groups of students after the intervention. So if you can look at the table, TM stands for teaching method. So there are teaching method 1, teaching method 2, teaching method 3, as well as teaching method 4. So the 4 teaching methods was given to the students in order for them to learn science. And at the end of the session, or at the end of the class, tests were given to the student to look at their achievement in learning science. So state null and alternative hypothesis as the first step that you need to do for ANOVA. And then what is your decision? If the null hypothesis is rejected, identify which group is stiffer and what is your conclusion. So when you get the data, what you need to do first, of course, you need to key in the SPSS so that you can analyze after you have keyed in everything or all the data in the SPSS. So the null and alternative hypothesis for this research would be there is no significant differences among the mean score with 4 different teaching methods to learn science after intervention. No significant differences among the mean score because ANOVA is an analysis to test mean difference with 4 different teaching methods, teaching method 1 until teaching method 4, to learn science after the intervention. And the alternative hypothesis would be there is a significant differences among the mean score with 4 different teaching methods to learn science after intervention. So once you key in all the data into the SPSS file, you go to Analyze and then choose General Linear Model, choose Univariate, and what you need to do is you need to key in your dependent variable, which is the score, the science score or the achievement score, and also the 4 teaching methods into the independent variables. And then you need to click Options, where you need to key in or you need to transfer teaching method from factors and factor interaction into display mean 4. And after that, under display, please tick descriptive statistic, estimate of effect size, and homogeneity test. And then make sure your significant level is at 0.05 of confidence interval or 95%. Click continue and then just click OK. So the output for your ANOVA is that firstly, you will see a between subject factors where it lists how many subjects there are in each level of the factor. Now you have 4 levels. And then it shows the descriptive statistics where it displays all the means, standard deviation, and the number of samples. So we have 5 for teaching method 1, 6 samples for teaching method 2, 6 samples for teaching method 3, and 5 samples for teaching method 4, where a total sample would be 22. Yeah. So by looking at descriptive statistic, what we can interpret is that the highest achievement or the highest mean score for this intervention would go to teaching method 4 with the value of 22, and the lowest would go to the teaching method 2. So this is just a descriptive statistics. One of the assumptions for you to fulfill in order for you to run ANOVA test is that equal variance must be assumed. So in order to do that, that's why we check on the homogeneity test so that the Levine test of equality of error variances can be done by SPSS. So from this output, the value of P is 0.255, or if we round up, it would be 0.26. Therefore, it is more than 0.05. And we can say that the 4 group, which is teaching method 1 until teaching method 4, have equal variance because the p-value is more than 0.05. Next, we're going to look at this table, which is teaching test of between subject effect, where in this test of between subject effect, what you need to, or which row you need to read would be the teaching method, which referring to your independent variables. Okay, so just read this row and look at the significant value. Here, the significant value for the independent variable would be 0.000, which means the p-value is less than 0.05. When the p-value is less than 0.05, therefore, the null hypothesis is rejected. Hence, there is a significant differences among the mean score with 4 different teaching methods to learn science after the intervention, because the p is less than 0.05. And don't forget to read on the partial eta squared to look at the effect size. So here, the value of effect size is 0.618, which if we convert it into percentage, it is approximately 62% of the variance of the dependent variable is associated with the group factor, or by following to the rules of thumb, the value of 62% is considered as having large effect. So now, since the test of between subject effect show there is a significant difference, or you rejected the null hypothesis, we want to know which mean score among the group would have mean different from one another. Because if the p-value for ANOVA or test of between subject effect is significant, it indicates that at least two groups from the independent variable have differences in their mean score. But we do not know which group are different in terms of their mean score. So therefore, we need to run a post-hoc test or multiple comparison. So in multiple comparison or post-hoc test, you do the same thing. You go to analyze and then you key in your IV and your DV. But this time, you click on post-hoc. So at the post-hoc dialog box, you need to key in, or you need to transfer teaching methods from the factor box into the post-hoc test. So you just key in teaching methods into post-hoc test, and then you can choose what analysis that you want, SPSS to run for post-hoc. You can choose LSD, Bonferroni, or also Turkey test. And then you just click continue and OK. So from this post-hoc test, what we can see is that for teaching method 1 and teaching method 2, the p-value is 0.005. For teaching method 1 and teaching method 3, 1 and 3, the p-value is 0.015. So these two show p-value less than 0.05. So in this case, there is a significant difference of the mean score between these two groups, teaching method 1 and 2 and teaching method 1 and 3. But how about teaching method 1 and 4? The p-value is more than 0.05. Therefore, there is no significant difference for the mean score between teaching method 1 and 4. Other than that, teaching method 2 and 4 also show a p-value less than 0.05. And teaching method 3 and teaching method 4 also show p-value less than 0.05. Whenever the p-value is less than 0.05, there is a significant differences of the mean score. For teaching method 1 and 2, teaching method 1 and teaching method 3, teaching method 2 and teaching method 4, as well as teaching method 3 and teaching method 4, in order for them to learn science after the intervention. So from this table, group teaching method 2 and teaching method 3 are listed in the same subset. Therefore, they are not significant different. They are equal. So group teaching method 1 and teaching method 4 are listed in the same subset also. Therefore, there are no significant difference. So subset 1, we can see that teaching method 2 and teaching method 3 they are in the same subset, as well as teaching method 1 and teaching method 4, they are also in the same subset. This indicates that there is no significant difference between the groups. Yeah? And from the profile plot, we can see that the lowest mean go to teaching method 2, followed by teaching method 3, followed by teaching method 1, and the highest mean score would belongs to teaching method 4. Yeah, this is how we read profile plot, which you need to include in ANOVA. As a result and conclusion, where you need to write it in the APA form, a one-way ANOVA was conducted to compare the effect of teaching method on student achievement to learn sign. There was a significant effect of teaching method on student achievement to learn sign, where the p-value is less than 0.05, and you have to write down in this way with F, df for ANOVA and error 318. Where you get 318, you got it from here. df for the independent variable, the df is 3. For the error is, the df is 18. So F in bracket 318, referring to the degree of freedom, equal to the F value, which is 9.695, where P is equal to 0.00. So since the P value is less than 0.05, post-hoc comparison using Tukey HSD test was done and indicate that the mean score for teaching method, this is the mean and standard deviation, was significantly different than the teaching method 2, teaching method 3, but not significant different with teaching method 4. The result also showed that there was significant difference in the mean score for teaching method 2 and teaching method 4, and also teaching method 3 and teaching method 4 to learn science after intervention. Meaning that you have to explain, or you have to write down all the significant value for the post-hoc test, yeah? Comparing the mean score among the groups. And then the partial eta squared value is 0.618, where it indicates that approximately 62% of the variance of the dependent variable is associated with the group factor, or having a large effect. Thus, the finding indicated that teaching method has an effect on student achievement after the intervention. So this is the way of how you write the APA format for the result and also conclusion for ANOVA. Okay, so this is again how to write a report using APA style. You write the ANOVA output first, or you write the analysis for ANOVA, and then you report the post-hoc, yeah? So this is another example of one-way ANOVA report, right? Where you can follow this. There are two ways, but anyhow, you need to write the analysis for the one-way ANOVA first, and then you need to write the analysis of the post-hoc, yeah, or the multiple comparison, and then you need to write on the effect size as well. And finally, what is your conclusion? So thank you very much for listening to this second example of how we can run ANOVA. So please remember, if your ANOVA result or ANOVA test is not significant, there is no need for you to proceed with the post-hoc test. You will only need to run post-hoc test if your ANOVA test is significant. So thank you very much for listening, and all the best for you in running one-way ANOVA. See you. Bye-bye.